Welcome back. In this video, we will be discussing the properties of matter. A property is any characteristic that can be used to describe or identify matter. Properties of matter are divided into chemical properties and physical properties. Chemical properties are characteristics that involve a change in the sample's chemical makeup. For example, the heat of combustion of a substance determines how much heat is released when a particular substance is burned. In order to measure this property, the substance must undergo a chemical change, which results in the substance of interest being converted into one or more new substances with different properties and compositions. Chemical changes, also known as chemical reactions, are discussed in later videos. Physical properties are attributes that can be measured without changing the sample's chemical makeup. Physical properties can be either extensive or intensive. An extensive physical property depends on the amount of matter in the sample. For example, I have two strips of magnesium. One is 10 inches in length, while the other is 5 inches in length. This property can be measured without changing the magnesium into a different substance, and the difference in length is the result of the amount of magnesium in each strip. Other examples of extensive physical properties include size, shape, mass, and volume. An intensive physical property does not depend on the amount of matter in the sample. For example, ductility is a solid material's ability to deform under tensile stress so as to be stretched into a wire. Gold, the most ductile of all metals, can be stretched into long, thin wires. This ability is not hindered by how much gold is in a particular sample. All sample sizes maintain the same ductility. In contrast, the overall length and diameter of the resulting gold wire are extensive properties and would, therefore, depend on the sample size. Other examples of intensive physical properties include malleability, density, color, and boiling point. Let's discuss boiling point. As we just learned, the boiling point of a substance is an intensive physical property. For water, the boiling point is 100 degrees Celsius. Whether you have a cup of pure water or a swimming pool of pure water, both samples will boil at exactly 100 degrees Celsius. When the water undergoes boiling at 100 degrees Celsius, it converts from a liquid phase into a gaseous phase. This change in its physical state is called a physical change. Physical changes can occur between any of the three states of matter, and all physical changes are intensive physical properties. Physical changes do not change the chemical composition of a substance, unlike chemical changes. A solid undergoes melting in order to become a liquid. A liquid undergoes vaporization to become a gas. A solid can directly become a gas through sublimation. All of these physical changes are reversible. A gas undergoes deposition to reform a solid. Or a gas can undergo condensation to reform a liquid. a liquid undergoes freezing to reform a solid. All of these properties discussed in this video are applicable for pure substances, either pure elemental substances or pure compounds, and can be utilized to separate components of a mixture. The most common methods of separating mixtures are distillation, filtration, and chromatography. Distillation is utilized to separate different liquids from a solution based upon their boiling points. The substance in the mixture with the lowest boiling point will vaporize out of the mixture before any other substance with higher boiling points. For example, a mixture containing ethanol and water can be distilled to separate the ethanol out of the water. The boiling point of ethanol is 78.4 degrees Celsius. This is significantly lower than the water's boiling point at 100 degrees Celsius. Once an ethanol-water mixture is heated and reaches 78.4 degrees Celsius, the ethanol in the mixture will vaporize. The ethanol gas is captured, cooled, until it condenses back into a liquid and collected in a separate container. Filtration is utilized to separate a heterogeneous mixture that consists of a solid and a liquid. The mixture is poured over a filter paper, which allows the liquid to pass through but captures the solid. Chromatography is utilized to separate components of a liquid solution or a gaseous solution. This method utilizes two different states of matter, a stationary phase and a mobile phase. The stationary phase is a solid and the mobile phase is either a liquid or a gas. The components of the mixture separate depending upon their similarity or affinity for each phase. A component with a high affinity for the mobile phase will move quickly through the chromatographic system. However, a component with a high affinity for the stationary phase will move very slowly. The rates at which the components move separates them for further analysis and identification. These and many other techniques are used to physically separate mixtures into pure substances. The only way to change one pure substance into another is using a chemical change.